Ever wondered what happens when a massive star explodes in our galaxy? Join us to uncover the dazzling secrets of this cosmic event. Earlier on, NASA gave updates about the discovery of a massive star that is fast approaching the end of its lifespan. This discovery has gotten the interest of many scientists who spend their lives studying the life and death of massive stars. And where it starts to get interesting is that this interstellar discovery, known as Eta Carinae, is predicted to explode not just as an ordinary star, but as a supernova. Yes, a supernova. Contrary to our sun, which has about 10 billion years left, stars like Eta Carinae can only survive a few million years. Their explosion often leads to the creation of heavy metals that contribute to the formation of other stars and planets. But that's merely all there is to it. In this video, we'll discuss what else comes on the heels of Eta Carinae's massive explosion. Keep watching. Before we begin, let us understand what a massive star is. A massive star is commonly classified as one with a mass of 8 to 100 times that of our sun. These stars have various distinguishing attributes that make them distinct from their smaller counterparts. First, they have extraordinarily heated surface temperatures, which may range from 30,000 to 50,000 Kelvin. This extreme heat adds to their stunning luminosity, which can be up to 1,000,000 times brighter than the sun. Massive stars can also outshine whole star clusters due to their brightness, making them very much visible in the night sky. This brightness comes from the fact that the center of large stars experience fast nuclear fusion, turning hydrogen into helium at an amazing pace. This not only creates enormous amounts of energy, but also allows the star to burn brilliantly while maintaining its structure against gravitational collapse. However, this rapid rate of fusion results in a far shorter lifespan than lower mass stars, which can burn for billions of years. That's why massive stars generally live only a few million years, completing their life cycles at an incredible rate. A massive star's life cycle begins in vast molecular clouds, where gravity attracts gas and dust. As the material compresses, it warms up and becomes a protostar. When the core temperature reaches a certain threshold, hydrogen fusion occurs, and the star enters the hydrogen-burning main sequence phase. During this period, it remains stable, converting hydrogen into helium and producing energy to help the star resist gravitational collapse. As the hydrogen in the core depletes, the star expands into a red supergiant, which is distinguished by a large rise in size and a lower surface temperature. During this stage, the star begins to fuse heavier components such as helium, carbon, and finally iron. The fusion processes continue until the core is mostly iron, which cannot create energy via fusion. When the core collapses under gravity, the outer layers are ejected in a magnificent explosion known as a supernova. This represents the conclusion of the star's life cycle. Depending on the originating star's mass, remnants of the explosion can produce neutron stars or black holes. Thus, the emergence and demise of massive stars contribute to the cosmic matter cycle by replenishing the interstellar medium with heavy elements required for planet formation and life. Massive stars influence their environment over the entirety of their lives. Their powerful radiation can cause surrounding clouds to begin forming new stars, and their stellar winds can carry gas and dust away, altering the interstellar medium. Hence, massive stars are distinct celestial objects with high temperatures, great luminosities, and brief life cycles. They are the focus of astronomical study because of their fascinating creation of supernova, which further shapes the vastness of the universe. So, which massive star are we talking about here? It is Eta Carinae, the massive star that floats on the verge of exploding, and it is found in the southern constellation of Carina. Eta is one of the faintly distant massive stars, situated around 7,500 light-years from Earth. With a mass estimated to be 150 times that of our sun, it is one of the most massive stars known and is classified as a light blue variable, LBV. For years, scientists have been fascinated by this massive star due to its remarkable brightness and distinctive blue color, which are attributed to its elevated surface temperature, thought to be more than 25,000 kelvins in addition to its sheer size. Eta Carinae's life cycle is really fascinating. It started when fast nuclear fusion of a big star produced helium from hydrogen. Massive amounts of energy were produced by this process, which kept the star's structure intact against gravity collapse and allowed it to shine brightly. However, when its hydrogen fuel ran out, Eta Carinae underwent a dramatic transformation, growing and becoming unstable. As one of the brightest stars in the sky, Eta Carinae experienced a huge outburst in the middle of the 1800s. This was such a big occurrence that it was seen during the day. Like most large stars reaching the conclusion of their evolution, the star's temperature and brightness have changed since then, and recent observations indicate that Eta Carinae is getting more unstable. When astronomers studied its spectra and light curves, they found signs of surface activity and pulsation, which suggest it is nearing the end of its life. Complex interactions between the stellar outer layers and the extreme radiation pressure coming from the star's core are what produce the variability of the star. Massive and dramatic eruptions usually accompany the development of Eta Carinae, and a number of circumstances often lead to this. Possible outcomes include a catastrophic explosion caused by a rapid collapse of the core. An even more spectacular but less disastrous outcome might occur if the star were to lose its outer layers prior to the core collapsing. Whatever direction it happens to come from, astronomers, both amateur and professional, anticipate that the next eruption of Eta Carinae will be historic. Given its position in the sky, which makes it visible to the naked eye, millions of people will have the chance to observe the star's final explosion. Scientists are already gathering information about Eta Carinae and the greater dynamics of stellar growth as they continue to watch the star. Eta Carinae is essentially a fascinating case study of a massive star nearing the end of its life. Its location, instability, and possible supernova make it an interesting subject for further astronomical research. Let's now explore the imminent explosion of Eta Carinae, which is making people's anticipation and intrigue increase by the hour. Once Eta Carinae eventually explodes and becomes a supernova, it will be nothing short of spectacular. Once the core collapses due to gravity, an impressive amount of energy that is equal to the total output of the sun's lifetime is what Eta will release. The massive star will see a flash of light from this cataclysmic event that might briefly eclipse whole galaxies, making it one of the brightest objects in the night sky. As the external layers of the star are emitted into space at impressive speeds, they will cause a shock wave that goes outward, which will compress other gases and dust around. Not only will this explosion be spectacular to see, but it will also set off other events, such as the discharge of neutrinos, which are basically particles with no mass that travel nearly at the speed of light. The discovery of these neutrinos will give scientists valuable data on the processes involved in the cosmic explosion, enhancing their study of supernova dynamics in real time. A developing cloud of gas and particles that will continue to shift over time is the residue left behind by the explosion. In the end, this residue will cool and contribute to the cosmic matter cycle by creating new stars, planets, and maybe even solar systems. The core of Eta Carinae might crumble into a black hole or a neutron star depending on its mass. Black holes are enormous portions of space occupying so much gravity that not even light, as fast as it is, can escape. Neutron stars, on the other hand, are very compressed objects mostly made up of neutrons. Noticeably, Eta Carinae is going to be brighter in the night sky when seen from Earth. Millions of people might be able to see this amazing cosmic event because it's one of the brightest space matter to be seen even during the day. In addition, the explosion will produce gravitational waves, which are space-time anomalies brought on by massive objects accelerating. These waves are observable from Earth-based observatories, which can also offer further details about the explosion. This supernova will have a significant impact on the environment. The shock wave from the explosion will strike nearby interstellar material, perhaps leading to the formation of new stars. And if exoplanets are anywhere near the vicinity, the shock wave can alter their orbits or atmospheres, changing the environment around them. Future generations of stars and planets will have a foundation made of heavy elements from the ejected material that will fill the interstellar medium. In addition to these immediate effects, the explosion will also affect the cosmic environment in the long run. The explosion's constituents will mix with the interstellar gas and dust already present in the galaxy to increase its chemical variety. Its need for the formation of new stars and planetary systems usually makes supernovae significant components of the cosmic matter cycle. The impending supernova of Eta Carinae is very significant in the field of astronomy and astrophysics. Observing this event will give insights into the latter phases of stellar development, which is an essential field of study for understanding the life cycle of massive stars. From it, scientists can obtain a better knowledge of the processes that lead to supernovae by examining the explosion of Eta Carinae, such as core collapse mechanisms and star material ejection dynamics. Furthermore, the explosion will provide an unprecedented opportunity to learn more about neutron stars and black holes. The residues left behind by a supernova can aid researchers in understanding the attributes of these strange objects, such as their mass, density, and behavior under severe circumstances. And of course, understanding how massive stars evolve into neutron stars or black holes is critical for our understanding of fundamental physics. The chemical enrichment of galaxies is another significant component in studying Eta Carinae's explosion. When massive stars burst, they emit heavy elements like carbon, oxygen, and iron into the interstellar medium. These elements are essential for the production of new stars, planets, and maybe life itself. By examining the nature of the elements expelled during the explosion, scientists can learn more about the mechanisms that contribute to galaxies' chemical development. Astronomers are continuously studying Eta Carinae, using powerful telescopes and devices to gather data and prepare for the inevitable explosion. At the moment, there is ongoing research which involves examining the star's light curves, spectra, and surface activity to acquire insight into its current status and forecast its future behavior. This particular method of inquiry enables scientists to gather as much detail as possible before the supernova bursts. Also, the impending event has caused popular interest in astronomy, making people gaze up at the night sky every now and then, admiring the wonders of the universe. Public outreach initiatives are also seeking to engage people about the essence of Eta Carinae and the science surrounding supernovae. Schools, planetariums, and observatories are hosting activities and debates to exchange information and promote interest in the galaxy. The coming explosion of Eta Carinae is more than simply a spectacle. It is a huge chance for scientific discovery. This event's insights will help us better understand stellar development, neutron stars, black holes, and galaxies' chemical richness. Eta Carinae's impending supernova is a very promising phenomenon that shows the life cycles of massive stars. While we're waiting for this all-spectacular explosion, let's hope it reminds us of the many wonders and secrets of the universe still waiting to be discovered. This event will not only brighten our night sky for a while, it will also expand our understanding of star development and the processes that form our universe. Thanks for watching. If you enjoyed this journey through space, don't forget to hit the like button and subscribe for more cosmic adventures. See you in the next video.